Hi, welcome to Theoretically Practical. My name's Brent. Today we're going to be talking about silver brazing repair. And it's a little bit of a topic. I haven't seen a lot on it on YouTube or anywhere else, but it's a really handy way to repair anything that's primarily copper. So like any bronze or copper or brass or anything like that, you'll be able to use this on. And it should also work for stainless steel repair as well. I think it's about 5% silver. We'll put the actual chemical composition right there, and there'll be a link to what exactly this is in the description. This is a Harris product. I actually got it because on my 52 Buick, I poked a hole in the radiator by dropping it on a jack stand, which was one of the better decisions I've made. And I was able to actually take a little piece of copper, put it over the hole I had poked, and use this to braze it in place. It's much, much stronger than solder, and it flows a little less, so you can actually kind of build it up a little bit more like a TIG or like a Braze. So this is really handy stuff. That radiator has heat cycled a few times and held pressure, no leaks, no problems. It's really good about stuff like that. It's quite strong. So the repair at hand, of course, because I wouldn't just bring it up for no reason, is this. And this is a heat exchanger out of a TIG torch cooling thing. My buddy picked up a Miller Synchrowave, and I'm a little jealous, but what can you do? And it came with a chiller, and he plugged it in for the first time, found out the previous owner probably put water in it, probably forgot about it. So there's a little hole right there, and there's another little hole somewhere in there, which is gonna be really fun to get at. I've got some ideas and it'll be interesting. So we're gonna repair that. We're gonna use silver brazing instead of, say, TIG brazing or any of the other methods, because it's gonna be a much more controllable. It's very thin wall tubing, so if I hit the pedal too hard, you just blast it apart and you'd never be able to get it back together again. Whereas this will never really get hot enough to melt the parent material. So, and why we aren't using regular solder to fix it is because it's pretty hard to bridge a gap with regular solder. I mean, these are less than a 1/16 of an inch, but with regular solder, it's just gonna wanna wick away, and it's not gonna last either. I think over time, heat cycles and stuff, you'd have issues with that, potentially. And also because I've used this before, I really like the results. So that's what we're doing today. Let's get started. So before we get going, we're just gonna talk a little bit about the tools that you need. I've got my MAP gas over here. I just tested it. This will work, but you have to really heat the hell out of the area in order to make it work. Overheat it, I would think. And it's not got the pinpoint accuracy you need. If you had one of the little mini torches that use a MAP gas and like another oxy tank, you'd be just fine. But this is not really going to do the job. Though I will use it to start my torch because I don't know where my clicker is. So I would not use this. I also have this. This is the cutting head for my oxyacetylene torch. I would also not use this. It's going to be way too much heat. You're going to blow apart whatever you're working on. I just wanted to specifically say don't use one of these. But what I do have here is a number 0 orifice torch head, which is good for the job. I'm probably going to try to use this, but if the area ends up being way too tight, I have this little oxyacetylene micro torch or jeweler's torch, depending on what you call it. And I don't think it has much of a smaller orifice per se. The number 0 is a pretty small orifice, but this is number 5. I don't know what the numbers mean, I'll be honest. But I've had this for a while. It works well. This will be what I use to get in when it's really tight. On the other end of things, you've got your oxyacetylene tanks. Those micro torches can be attached right there. So same regulators, just the different torch ends. If you ever find one of these for cheap, I recommend picking it up. They're really nice. It's great for really tiny repairs. This is gonna be our test piece for today. I drilled a 5/64, so it's even bigger than a 16th hole in it. This is bigger than what we're gonna have to try to cover over. And I just haven't done this process in a while, so I want to be able to try it somewhere where I'm not space constrained and I've got plenty of room. And even better yet, I'm going to put a cover over this lens and you're going to be able to see what I'm doing, because in the actual heat exchanger, you're not going to see anything. I probably won't be able to get a good camera angle. So this lets you get a good camera angle and lets me get some practice. So I'm going to tape the lens out of one of these right over that, and we'll see how well it works. I did a little test earlier, and it's much better with this one than without it. So, yeah. All right, so you're gonna want a neutral flame for this. And so right now, I have a carburizing flame. You can see that big area. And then you can see as I close off the oxygen, it becomes more carburizing, which just adds carbon from the acetylene. And then as I open it up, you get to be a neutral flame right about there. And if I keep opening up, you have an oxidizing flame. You can hear that extra oxygen coming out of it. You don't want that either. So you just want that as it comes in, boom, just when it sharpens out and no more. So, and this is, I'm only running a few, 8 pounds of pressure on the acetylene. We have our little hole right here, which I'm trying to illuminate with the torch. It's right there. And we're going to warm it up a little bit. And I don't have the flux that I would like to have. I cannot find it. But I'm just going to warm this up with the torch just briefly. And just put some flux on it. There we go. And it's soldering flux. It worked in my test. So, and then we're going to take the rod right here. And we're just going to heat it up. And there you go, a little bit on, a little bit on. And that's it, right there. That hole, you saw that hole covered over nicely. I am going to try to just gently heat it up a little bit more, because I think I overheated it a little bit. There we are. And there you go. So the spot we repaired was right there. You can see there's this nice cover over it. There's no porosity to it, and that's it. It's really simple to do, and I think with a TIG or anything else like that, you'd blow it apart. So we're going to try to get access to the really difficult repair, and then we'll get back to this. All right, so I did another check. My buddy had put a purple mark on the outside of the disc. And looking at that, the damage is in the second row in the backside looking that way. And we'll put a picture over there. I actually managed to get a pretty good picture of the damage. So I need to access the backside of that. And I'm thinking the only way to do that is to remove some of these fins from this section here. So I don't know. I don't know if there's a better way to do it. You know, if you got any ideas, let me know. I'm always looking for better ways to solve things. But, and I thought, how do I get those out without, you know, really screwing it up? Because they are semi-captivated on this. And what I came up with is I'm going to take a scroll saw and cut these 4 out here, and then I'm actually, because it's on that pipe, gonna cut these 4 out here and then remove as much of the little pieces as I can by pulling them out with a pair of pliers. So I kind of wish there was a better way to do it, but I think that'll do it. And again, you know, there's no way to repair it without taking some of these off. We did talk about cutting this strap and opening it up, but I don't think there's a chance that we'd get it back together again well enough to work. Whereas I think this, you're gonna lose just a tiny bit of potential for heat. So I'm gonna get my scroll saw, which has been a way more useful tool than I would have ever thought. And we're gonna make this happen. All right, this is my little Delta variable speed scroll saw. I picked it up for a project a while back. It was the closest one on Facebook, but it's pretty nice. I like how it clamps, has the clamping style of blade holder. It means you don't have to use blades with the little handles on it, and it does mean that they tend to, it's gonna fit right through those heat exchangers, which is why I'm using it. It's not what I'd consider like the best tool for the job, but it's the best tool that I have for the job. Well, we have a wood cutting blade, a wood cutting blade, or a wood cutting blade. So we'll use the wood cutting blade, even though it's not what I would consider entirely correct. You got the blade here, it's through the heat exchangers. We're trying to cut out 4 or 5 of these outer ones to get some access in there. And hopefully this works okay. Oh, this is also gonna be just absolutely atrociously loud. I guarantee it. Whoa. All right, that's number 1 out. Look at that, that came out surprisingly easy. I'm just gonna take a look and make sure I'm not damaging the copper pipe, but no, there's, oh man, I am thrilled. I did not think that this was gonna be quite that successful. So we'll turn it on. We'll go faster, because that'll make it better. Okay, we're gonna open that up, pull this out. Oh yeah, yep, we're definitely gonna have to take a few out on the other side, but I don't know if you can see down in there now. Yeah, you can. That little greenish spot right there is the hole. So now we've got enough access for the torch, especially maybe the micro torch up from the bottom. I'm not sure, but I got enough room for the torch. But we're gonna have to take out 1, 2, 3 of those and then push the middles out as well on the inward one, just so where there's aluminum right next to it, we don't want to, it's just going to make a mess. So we're just going to take out those as well, and then we should be good. I did all that, cutting real close to the copper tubing on the inside, didn't nick it at all. So, man, I guess I must know what I'm doing once in a while. I'm trying not to sound surprised at my own success, but let me tell you, I'm surprised at my own success. All right, that should do it. Okay, now we have room to work. Okay, so you probably can't see the crack, but it's down that hole, but I have enough room so I can take the torch and put it in there at a nice angle, and I'll also be able to feed my rod right in there, and that should be good. I'm gonna warm it up a bit, and then I'm gonna get as much flux as I can on that, and we'll light the tires, kick the fires, something like that. It'll be good. Kick the tires, light the fires. Wow. I can speak. Also, working with copper and aluminum on cold days, you just can't beat it. So that's the same neutral flame you saw before, but with the without the lens. Oh, that was good. Okay, now that I figured out that I have my tanks off, I'm ready to weld. So I'm gonna turn it down. Right there. You guys are right in my way. Okay, now I gotta get some flux in there. This flux is not flowing super easy today. There we go. Get it right on there. I have never in my life felt like I put too much flux on anything, so there we go. Nice sharp flame. I should move this off the edge of my table. Keep lighting my table on fire. Really shouldn't be doing that. I will be double checking this and revisiting it once I get the other one plugged up. And there you can see it. So that little lump in the middle is the repair. I'm pretty happy with that. This was definitely a maybe this will work situation. Ryan, who I promised this would absolutely work, you know, hey, it did work. That's all that matters. All right, so we got this pretty well fixed, considering it's a $150 part and it took me like $3 in materials and about an hour to fix it. And also knowing that this friend has a really nice, fully CNC shop at his house. And if you got a buddy like that and you can get him to owe you a favor, it's a smart move. So we'll just go ahead and confirm. And yeah, I mean, if I had, you know, a connection for this so I could put like 10 PSI in it, spray the whole thing down, but I can tell right now that this is definitely not leaking in any reasonable form. So I'm pretty happy with how this repair went. I think my buddy's gonna be thrilled because he just saved 150 bucks. And yeah. And that's all for this week. It's kind of short, but needed to happen. So, yeah, until next time.